This problem is from GATE 2021 Mechanical Engineering paper of Set 1. The question says, in which of the following pairs of cycles, both cycles have at least one isothermal process? So the four options given to us are diesel cycle and Otto cycle. Second is Carnot cycle and Stirling cycle. Third is Brayton cycle and Rankine cycle. And fourth is Bell-Coleman cycle and vapor compression refrigeration cycle. Now let's understand all the cycles using PV diagram. So the first cycle that we are going to see is diesel cycle. Let's see the PV diagram of diesel cycle. Now the diesel cycle is used in IC engines and this is also called as constant pressure cycle. So pressure is constant. So why it is called constant pressure cycle is because heat is added when the pressure is constant. So Q in. So the first stage of the cycle from 1 to 2, it is isentropic process. So here work is done in the system. And 2 to 3 is a constant pressure cycle, constant pressure stage in which heat is added. And 3 to 4 is also isentropic process where work is done by the system, work out. And at constant volume, heat is rejected from this cycle, Q out. So we see here there is no isothermal process in this diesel cycle. Now in our list, the second cycle is the Otto cycle. Now this is a PV diagram of an Otto cycle. Now you see here the first stage is isentropic compression in which the work is done in the system, W in. This is isentropic process 1 to 2. 2 to 3 you can see here it is constant volume, heat is added in this process. From 3 to 4 it is again isentropic expansion. So work is done out of the system. And 4 to 1 is heat is rejected from the cycle. So heat out, and 4 to 1 is also constant volume stage. So in this cycle also we see that there is no isothermal process happening. So in Otto cycle there is no isothermal process going on. Now option B is Carnot cycle and Stirling cycle. So let's first see the PV diagram of Carnot cycle. So in Carnot cycle, stage 1 to 2 is isothermal compression. This 1 to 2 is called isothermal compression. Now process 2 to 3, this is adiabatic compression. The process 3 to 4 in which heat is rejected, that is isothermal expansion process. And the fourth process, that is from 4 to 1, is adiabatic expansion. So we see here in this Carnot cycle, we have two isothermal, that means from process 1 to 2 and 3 to 4, the process takes place at constant temperature. Now let's look at the second cycle, that is Stirling cycle. Now let's look the PV diagram of Stirling cycle. The Stirling cycle, a Stirling cycle engine is a closed cycle regenerative heat engine. In process 1 to 2, heat is added in the system at constant temperature. So temperature remains constant. So this is a isothermal curve. 1 to 2 is isothermal. So process 1 to 2 is isothermal. And process 2 to 3 is constant volume process. Again process 3 to 4 is isothermal process in which heat is rejected from the system. So this is process 3 to 4 is also isothermal process. In our question it was asked that we need to name a pair of cycle, so in which both cycle have at least one isothermal processes. We see here in the Carnot cycle and the Stirling cycle, there are two isothermal processes here. So option B is the correct answer. But let's have a look at other four cycles given in the options. So the third option is Brayton cycle and Rankine cycle. So let's see the PV diagram of a Brayton cycle and the Rankine cycle. The Brayton cycle is a thermodynamic cycle that describes how gas turbine operates. In Brayton cycle, process 1 to 2 is isentropic process, that is entropy remains constant. And process 2 to 3 and process 4 to 1 is a constant pressure process. In 2 to 3, heat is added in the system, and in 4 to 1, heat is rejected from the system. Process 3 to 4 is also isentropic process. So that means entropy remains constant. So we see here also there is no isothermal process in Brayton cycle. Now let's have a look at the PV diagram of Rankine cycle. A Rankine vapor cycle is the process widely used by power plants such as coal-fired power plants or nuclear reactors. So in the PV diagram of Rankine cycle, you can see here process 1 to 2 is isothermal expansion and heat is added here in the system. So this is T is equal to constant. Process 2 to 3 is isentropic expansion, that is entropy remains constant here. From process 3 to 4 is again isothermal compression. Isothermal compression, that means heat is getting out from here of the system. And 4 to 1 is constant volume cycle. Now you see here that there are two isothermal processes, process 1 to 2 and 3 to 4. But in Brayton cycle there is no isothermal process. That's why this cannot be our correct answer, because the question clearly says that both the cycles have at least one isothermal process. Now moving on to our next cycle, that is Bell-Coleman cycle and vapor compression refrigeration cycle. Now let's see the PV diagram of these two cycles. Now let's first look the Bell-Coleman cycle. The Bell-Coleman cycle is also called the Joule cycle or reverse Brayton cycle. The Bell-Coleman cycle is a refrigeration cycle where the working fluid is a gas that is compressed and expanded here but does not changes the phase, and more often air is the working fluid in this cycle. Now the reason this cycle is called the reverse Brayton cycle is, you can see here, process 1 to 2 is isentropic compression process, that is entropy remains constant here. Process 2 to 3 and process 4 to 1 is a constant pressure cycle, and process 3 to 4 is a isentropic expansion, that is entropy remains constant here in this process. Now you will see exactly this is reverse of Brayton cycle. Since there is no isothermal process in Brayton cycle, in Bell-Coleman cycle also there is no isothermal process. Now the last one is vapor compression refrigeration cycle. So in the PV diagram we can see that process 1 to 2 is compression, process 2 to 3 is condensation, process 3 to 4 is throttling, and process 4 to 1 is evaporation. In process 4 to 1, heat is added in the system, and process 2 to 3, heat is rejected from the system. In the vapor compression refrigeration cycle as well, we see there is no isothermal process. And so since in Bell-Coleman cycle as well as in vapor compression refrigeration cycle, there is no isothermal process, so this option is also incorrect. One thing to know about vapor compression refrigeration cycle is that it is a compression process whose aim is to raise the refrigerant pressure as it flows and evaporates. Now in this problem, we saw the PV diagram of 8 different cycles, and we also saw that there are only 3 cycles in which isothermal processes take place, that is Carnot cycle and Stirling cycle and the Rankine cycle. Since Carnot cycle and Stirling cycle both are having this isothermal process, so our correct answer is option B. Now if you want to know more on thermodynamic processes, you must check out the basic thermodynamics lecture by Professor S.K. Som from the Department of Mechanical Engineering, IIT Kharagpur. Hopefully I was able to clear your doubt. Have a great day. Thank you.